Hello students, the next unit that we have to start today, that is the hydrogen. Hydrogen, the most abundant element in the universe and they are most abundant and third most abundant on the surface of the globe, is being visualized as the major future source of energy. Clear? Hydrogen is the most abundant element in the universe and also we can use it as a source of energy. So let's have a look at its position in the periodic table. Hydrogen is the first element in the periodic table. However, its placement in the periodic table has been subject of discussion in the past, but now it is the first element of the periodic table, and hydrogen has electronic configuration, that is 1s1, means only one electron in its valence shell with configuration 1s1, and its electronic configuration is similar to the outer electronic configuration of alkali metals. That's why it is kept in the first group of the periodic table, because of only one electron in its valence shell. On the other hand, like halogens, it is short by one electron to corresponding noble gas configuration, that after achieving one electron it can have the configuration of helium also, so same as in case of the halogens. So in terms of configuration we are also viewing that resemblance with the alkali metals, which lose one electron to form unipositive ions, as well as with the halogens also, which gain one electron to form uni-negative ion. Like alkali metals, hydrogen form oxides, halides and sulfides, and however unlike alkali metals, it is very high, it has a very high ionization enthalpy. Alkali metals very frequently lose its one electron. For example, Na needs less amount of energy to lose one electron to form ion, but in case of hydrogen, to turn it into H+, the amount of ionization enthalpy required will be high. What could be the reason? Smaller size of the hydrogen atom. Clear? And it possesses metallic characteristic under normal conditions. In fact, in terms of ionization enthalpy, hydrogen resembles more with the halogens, as halogens require large amount of energy to change into the ions. In a similar way for hydrogen, because of its smaller size, and halogens are having high electronegativity values. Fluorine is having nearly 1680 kilojoule per mole, and for hydrogen the amount of ionization enthalpy is nearly 1312 kilojoule per mole. Like halogens, it forms a diatomic molecule, like H2 molecule combines with the elements to form hydrides and a large number of covalent compounds. However, in terms of reactivity, it is very low as compared to the halogens. So in spite of the fact that hydrogen to a certain extent resembles both with alkali metals and halogens, it differs from them as well. Now the pertinent question arises as where should it be placed in the periodic table. Loss of the electron from hydrogen atom results in the nucleus, and this is extremely small as compared to normal atomic and ionic sizes of 50 to 200 picometer. As a consequence, proton does not exist freely and is always associated with other atoms or molecules. Thus, it is unique in behavior and is therefore the best placed separately in the periodic table. In the first group, we are having it, and starting of the periodic table is from the hydrogen because of its small size. Clear? Now, occurrence. Dihydrogen is the most abundant element in the universe, near about 70% of the total mass, and is the principal element in the solar atmosphere. The giant planet Jupiter and Saturn consist mostly of hydrogen. However, due to its light nature, it is much less abundant in the Earth's atmosphere. Of course, in the combined form, it constitutes 15.4% of the Earth's crust and oceans. In the combined form, besides in water, it occurs in plant and animal tissues, carbohydrates, proteins, hydrides, including hydrocarbons and many other compounds. Clear? So these are the sources for the hydrogen, or where we can see the occurrence of the hydrogen. And next, isotopes of hydrogen. Hydrogen has three isotopes. Prosium, in which one electron and one proton is there, and for deuterium there is one proton, one electron and one neutron, and for tritium there are two neutrons, one electron and one proton. So can you guess how these isotopes differ from each other? As I have said you that in case of prosium no neutrons, in case of deuterium we are going to have one neutron, and for tritium we are having two neutrons. So the predominant form is prosium. Terrestrial hydrogen contains near about 0.0156% of deuterium, mostly in the form of the Hd, and the tritium concentration is about 1 atom per 10⁻18 atoms of the prosium. So of these isotopes only tritium is the radioactive and emits low energy beta particles with a half life of 12.33 years. Clear?